The pressure vanished before anyone realized Earth's shield had never been standing on its own. In late spring of 1999, multiple satellites monitoring the space environment around Earth detected something that should have been impossible. The solar wind, the constant stream of charged particles flowing outward from the Sun at over 1 million miles per hour, had almost completely disappeared. Measurements showed a collapse of nearly 98%. And within hours, the protective magnetic boundary surrounding Earth began changing shape in ways no one had ever seen before. For decades, space physics had treated Earth's magnetosphere as a stable planetary defense system, a permanent electromagnetic shield generated by the planet's molten core, constantly blocking radiation and deflecting solar particles. Reliable, predictable, always there. But suddenly, the force pressing against that shield was gone. And the system immediately started behaving like something much less permanent. The first images arriving from monitoring satellites showed a structure nobody expected. Earth's magnetosphere, normally compressed tightly on the sun-facing side, had begun inflating outward like a massive, transparent balloon. Not gradually, violently. And that was the moment scientists realized an invisible dependency had been hiding inside one of Earth's most trusted protection systems. Because the shield protecting life on this planet was not standing freely. It was being held in shape by the sun itself. Under normal conditions, solar wind acts like a constant external pressure stream. Charged particles slam continuously into Earth's magnetic field, compressing it inward and forcing the entire magnetosphere into a stable, defensive configuration. The system had always looked permanent, because the pressure had never stopped. Until now. As solar observatories confirmed the collapse, spacecraft positioned across near-Earth orbit started recording dramatic structural changes. The magnetic boundary on Earth's daylight side pushed outward rapidly. The entire magnetosphere expanded several times larger than its normal dimensions. Imagine watching a sealed structure suddenly lose the force holding its shape together. That was what Earth had become. And that created a much larger problem. Because nearly every space monitoring model in operation assumed solar wind was constant. Satellite calibration systems, radiation forecasting systems, geomagnetic prediction software, orbital plasma interaction models. All of them had quietly built themselves around one assumption. The sun never stops pushing. And now that assumption had failed. But the physical expansion itself was not the dangerous part. What made the event deeply unsettling was what scientists began understanding next. The magnetosphere was never simply defending Earth against incoming particles. It was balancing against them. For decades, textbooks treated Earth's magnetic shield like armor. Something internally generated. Something stable. Something independent. But as the solar wind vanished, the shield expanded outward so dramatically that researchers realized Earth's magnetic environment behaves more like a pressurized mechanical system. A structure held in equilibrium by continuous external force. Remove that force, and the entire geometry changes immediately. The image returned again. A massive magnetic bubble surrounding Earth, now swelling outward far beyond normal operational limits. The exact same structure. Completely different meaning. And that changed the scale of the problem. Because this was no longer a strange solar event. This meant planetary stability itself depended on conditions outside the planet. Earth was not maintaining this defense system alone. The Sun was actively participating in holding it together. And suddenly, researchers started thinking about consequences nobody had seriously considered before. What happens if solar wind weakens longer? What happens to satellite radiation exposure models built around normal compression? What happens to charged particle movement trapped inside the Van Allen radiation belts when magnetic boundaries expand unpredictably? No one had answers. Because nobody expected the dependency to reveal itself this way. Then came the duration. The solar wind collapse continued for nearly 48 hours. 2 full days. That mattered because short fluctuations happen constantly. Small variations in solar pressure are normal. But a near-total collapse lasting this long had almost never been observed. The magnetosphere remained expanded the entire time. Space weather monitoring systems began recalculating environmental boundaries in real time as old assumptions stopped matching active measurements. And for the first time, scientists were forced to confront something uncomfortable. Earth's most important defense system was not self-contained. It required constant cooperation from the very object it was designed to resist. The Sun was not simply attacking the magnetosphere. It was shaping it. And without that invisible pressure, the system reorganized itself instantly. The same visual returned once more. Earth suspended inside an enormous magnetic bubble, stretching far larger than normal. At first, that image looked reassuring. A larger shield sounds safer. But now, its meaning had changed again. This was not strength. It was structural instability exposed in real time. Because the expansion proved the system protecting Earth exists inside a delicate balance nobody fully appreciated. One external force disappears, and the entire structure changes shape. No damage, no warning, no permission, just instant planetary reconfiguration. For nearly every human alive, the Sun feels like a distant source of light and heat. But for 48 hours in 1999, it revealed something far more unsettling. Earth is not protected by a permanent shield. It is protected by a system under constant pressure. And the moment that pressure stopped, the planet immediately became something different. The shield was never standing alone. The Sun was holding it in place.